Hey, g'day, it's Prezzo. Thanks for stopping by. Now, this is episode 4 of building a pair of replica Cleveland vintage race cars. Now, these are toy cars. They were cast in aluminium and they were made back in the 1920s and 30s. I've got a surviving example here that's over 100 years old, but I want to make 2 replicas. And in the previous episode, I made the tyres for the cars, and today I want to get on and make the wheels. Now, I made a playlist. There's a link up above there now if you want to go back and look at previous episodes. And we'll have a look at the tyres on the bench here in a minute because I've resolved some of the issues I had making those. And then, we'll get on and do the castings. Here's a stack of tyres that I made in the previous episode. Now, these were cast in a high-density polyethylene mould, and I used a 2-part polyurethane resin. And although I bought the correct pigment to make the tyres black, they all came out this sort of a medium grey colour. Now, these are the tyres on the original Cleveland racer. These are vulcanised rubber, so of course you get that nice black colour, but I just couldn't replicate it with the resin and the pigment that I had. So what I did instead was I went and bought a whole bunch of permanent markers, and I tried these out, and I found out that this one here is Artline 100, gave me the best result. So I've been working on a pair of these. There's 2 there that I've already done, and these need to be machined on the lathe. The inner surface needs to be trimmed up so we've got an accurate surface to work from, and then I was able to machine the outer face of the tyre. And although they've all got some defects and they're not perfect, I think they're okay, but certainly that gives me the colour and the sort of texture that I was looking for on the tyres. So what I want to do first though, before we go and machine these tyres, is to have a go at making the cast aluminium centres for each of the wheels. Now, I've got a pattern here. This will give me 5 half rims for the tyres, and I'll need 10 of these to make 5 tyres. So we'll get the moulds made up and we'll have a go at casting them, and then we'll do a bit of machining on the tyres and I'll show you how I finish them. And if we get time, we might machine some of the wheels themselves. All right, to the foundry. So this is the drag, and it just needs to be filled with sand. The pattern's actually going in the cope. And it's pretty easy because it's a one-sided pattern. So that's our drag. Pattern goes on top of that. So that'll form our tapered sprue, and there'll be a pouring basin over here. And there's no riser, so what I'll do is put a vent wire down through the top of each one of the pattern pieces. When you're making these offset pouring basins, it's really important that the bottom of that large basin there is completely flat. I used to make this sort of hemispherical, and it was pointed out to me by Martin West, old foundryman, that you pour the metal in, it will hit the bottom of that hemispherical surface and just flow straight back out again. So yeah, you want it to be like flat on the bottom and nice sharp edges around the inside. All right. Alright, that's looking good. So what I'll do is I'll push a vent wire down through the center of each one of those 5 patterns there, or 5 cavities, and that will allow air to escape through to the top of the cope. Alright, I'll get another one of those made, and yeah, we'll go ahead and pour them. Okay, I've got my 2 molds set up here now. This will give me 10 of the wheel halves, or enough to make 5 wheel centers. And over here I've got the burner cart set up and the furnace. And what I'm going to do is to melt down these failed castings. These were the car bodies that didn't work out. And in the comments on that video, somebody had mentioned that I should have just cut these down the center line, like from front to back, and made sort of framed and mounted half car models, which was a brilliant idea. But by the time I got that comment, I'd already cut these in half the other way, with a view to actually remelting them and using them to make the wheels. So yeah, opportunity lost there. And in case you're wondering, this burner cart here has been brilliant. I call it the Goldilocks burner cart, because everything that I purchased to make that was just right. So the blower, the fuel pump that goes in the fuel tank, the nozzle that goes inside the burner, and also the size and the other parts of the burner itself just worked out. And it's surprising because it was completely eyeballed. I'm no combustion engineer, but somehow or other I just managed to get all of those components right. So really happy with that. The diesel fuel is relatively cheap. It's safe to have around the workshop. Got a good high heat content when you burn it. And you can see from the inside of the furnace there that it's completely white. I always thought that diesel would leave a black soot on everything, but if you get the mixture right, the ratio of air and fuel, it just burns really hot and completely clean. So yeah, very happy with the setup. Okay, I'll get this lit up and yeah, we'll do the castings. When I get at the end of a casting session, I just turn the fuel pump off. I shut the main valve on the burner itself, but I leave the blower running. There's always some residual fuel inside the furnace that continues to burn. Just having the blower on helps to ventilate the inside of the furnace, but I want to melt some more metal, so I don't want to cool it down too much. So I'll just sort of let it run for another minute and turn the blower off, and then we'll turn out the molds, see how they went. Alright, they look really good. Super happy with that. You can see where the vent wire was allowing the metal to flow up to the top of the cope, and that just allowed the cavity to completely fill. Those little projections there are going to be chucking pieces, so I can grab that part in the 3-jaw chuck and machine the back off before I do anything else. So yeah, that's good. I'll get the other one out and then I'll make up 2 more molds. So I'll have 20 of these, but I might make a couple of extras just in case. Certainly better than the last effort. This is the second set. Okay, also successful. I'll get another set of molds made up. This is another really useful thing if you're going to do any sort of metal casting, is to make yourself a muller. Before I had this, I used to have to get down on my hands and knees and use my hands to break up the big lumps of sand. It was most undignified, and I'm too old to be doing that anyway. So this thing's brilliant. Takes about like 5-10 minutes to condition the sand. I can reuse it. This doesn't need a lot more moisture. It's already holding together. So it just needs to have big lumps broken up, and we'll just reuse it. But I took this idea from Lucky Gen 1001. He had made one almost exactly the same as this, so I just copied the idea. But it's on wheels, so I can put it away when I'm not using it. It just works brilliantly. There is a bit of post-processing required on these tyres, and that's mainly to clean up this outside surface here. As you can see, a line where the 2 halves of the mould join. But in order to do that, I need to machine the inside of the tyre to get a flat surface there. At the moment, there's a 110-degree included angle on the inside of the tyre, and it leaves sort of a sharp edge there. If I machine that off to a diameter of 48 ID, that will fit over my flexi chuck, and then we can grip it and do the outside of the tyre. I'll get this one set up. Now, sort of luckily, these tyres are quite stiff, so I can grip it in the outside jaws on the 3-jaw chuck without deforming it too much. But I'm not putting it in there really tightly, just sort of nipping that up, and that's all. And we'll just use the boring bar now to create that flat. So I've already got the DRO set. Just going to do 1 cut. It's quite soft and easy to cut. So that's that. I'll get all of them done that way, and then we'll do the outside. So this is my flexi chuck. I bought this from Eccentric Engineering here in Australia. It's a wonderful piece of gear. And this extension on the end is a consumable aluminium soft jaw, basically. So you can machine a recess on the inside of the soft jaw, or in this case I've machined a step on the outside. So you can grip parts by either expanding the jaws or collapsing them. So in this case I'm just going to put the tyre with that previously machined flat on the outside and just expand the jaws. And that's gripped quite firmly now, I think. Yep. And what I've got here is a form tool. Now I just ground this out of a piece of old file, And I've got everything set up. We'll just machine this out of profile here, and then I'll put the black outline marker on that one. That didn't quite clean up. I'll just do a little bit more. Alright, that's good enough for the demonstration. I've got spares of these tyres, so if there's a few that have defects in them like this one here, I don't need to use them. I'll go ahead and put the black marker on this one now. And I'll just flip it over and do the other side. Okay, now I know these aren't perfect. But like I say, I'll pick the best of them to go on the car. Yeah, so this one's got quite a few defects around the outside there, but it'll give you an idea of how it works. It looks pretty good from the outside. It's just this surface here where it has a lot of bubbles and defects. Right, that one's better, but yeah, not perfect. Well, there's the batch of tyres that are finished now, and I've got a half a tyre here which I've been using to check the profile of the wheel hub centre. Now, I've machined one of these up. This was a prototype. I did actually make 5 extra castings so I could prototype what this looks like on the inside. So I put one of the tyres in there, and this is the wheel that came on the Cleveland race when I got it. So I think it's a fairly close match, but it was getting this internal profile that was giving me a lot of headaches. So I'll dismantle this and I'll show you what it looks like with that half tyre profile inside it. Okay, you can sort of see how that tyre profile sits inside those 2 wheel halves. So there is that 110 degree included angle on the base of the tyre, or the inside surface of the tyre, and you need to have the matching angle on the 2 castings there. So I did actually make 5 extra castings so I could prototype this process, And I'm using one of these as my reference now. So when I go to machine the rest, I'll set this one up and I'll use the DRO to set the start and end points. And I've already got the taper turning angle set up. And yeah, it's just a lot of work with 20 of these to do. And I haven't machined the outside of the casting yet either. That's going to need setting up in a fixture so we can do some pressure turning to get all of this cleaned up. So what I'll do is I'll do a couple now on camera and I'll show you what I'm doing, but then it's just a matter of repeating that process over and over. Okay, I've got a saddle stop set up so that this shoulder is going to be the same on all of the castings, and the chucking piece is turned to 10 millimeters and we drilled right through with a 6 millimeter drill bit. So I'll go and do the rest. They're all the same, and then we'll come back and we're going to flip this around and machine the features on the other side. Alright, that's the correct OD and the correct thickness. I've got my DRO set up for the diameter and that dimension there. So I'll get them all processed at the same settings, and then we're going to cut the tapered seat for the tyre. Alright, so what I did there was I'm using the compound slide, and I set up the micrometer collar on the compound slide so it reads 0 when I get to the end of the cut, and I can set the start position or the end position, I guess, for that last cut with the DRO so it reads 0 when I get to the last cut. Sort of complicated way to explain it, but you need to be repeatable so I can do all of these and get them all the same. So I'll go ahead now, get them all up to this standard, and then we have to flip the part and machine the other side. So that's how I'm processing all of these. It's just a simple fixture, and I've got a ground form tool, and these are going to get sandblasted and powder coated later on, so I'm not too worried about getting a perfect finish on that. Even some of the casting texture that's showing through, that'll pretty much disappear by the time this is finished. So I'll get the rest of these done, then we'll put a pair of these together with a tyre in between. And I'm going to take off that little chucking piece on the milling machine, so I'll just fixture that up on a plate, use an end mill to lop that off. But yeah, turning out pretty good. Alright, you can see here all of the parts that I've made up to this point. Now, for these wheels, I took that little chucking piece off the centre of the wheel by mounting this on a pallet against a pair of dowel pins, and then I just used a 12mm end mill to take off the top of that chucking piece. And I just did them all in the same setup, so they're all the same height when they were finished. And you can see with this one here, I've got a piece of brass tube fitting through the wheel centres. Now this does two jobs. It aligns the two wheel centres, but later on that will get riveted over on both sides to form a hollow rivet, and that will hold the wheel halves together on the tyre. So this one here, you can see that that's ready to go. But I'm not going to assemble these until I'm absolutely sure that this resin that I'm using here is going to be correct. Now I'm currently talking to a supplier here in Australia to find an alternative, more flexible black rubber type resin. There was a lot of comments on this that came in on the last video, and there are lots of people sort of recommending different types of resin. There is one called Smooth On, which looks to be ideal, but it's not available here in Australia. There is a company that has a similar product, and I did a product inquiry with them, and they're sort of recommending a couple of different ones that will work. The downside with any of these sort of more flexible resins is the cure time. So usually it's between 24 and 48 hours, and if you've got to make 5 tyres, that slows down the whole process. So the resin I did use was good because the cure time was so short. The downside is that it didn't come out black, and also it's quite dense. So these are not flexible at all. So on the static display car, this type of tyre here will be fine, but for the running car, the one that's going to get used as a toy, I want that to be a more rubber-like resin, so that's what I'm looking for. Now there was a viewer named Vlad who got in touch with me. He's got a resin printer, and he asked if he could print one in a resin called Flex, and I've sent him the STL file, and he's doing that now, so he's going to send it back to me to evaluate it. So I'm not going to assemble any of these wheels until I'm sure I've got the correct combination of resin or rubber type tyre, and then I can do all of that work. So you're probably looking at these two tyres and wheels here and saying, well, hang on, they're not exactly the same. Now remember, this one here is not an original Cleveland racer wheel. This was a replica that was purchased in New Zealand about 30 years ago, so it's not the same. This one here, the profile that I've used, I took off a photograph from a website that claims to sell the replica original Cleveland wheel. So this is the photograph I found, and I based the profile of the wheel center off that photo. So these are more correct, I guess, for the original Cleveland racer. So that's where we're at the moment. In the next episode, we're going to polish up the castings. And this is the original car, by the way. But we're going to polish up the castings. I'll give you a sneak preview of what that looks like. So I've actually already done it, but we'll see next time how that went. And then we've got to get on and drill some holes, make some axles, and the fun part is going to be making that little steering wheel. Now I didn't even think about this. That's actually made of cast iron, and I can't imagine the work that we're going to making something that small from a pattern that doesn't have a regular split line. So this would have to be put into a mold, and then you'd have to cope down to find the actual split line for that three-dimensional form. So I've sort of come to the conclusion the only way to do this is to CNC machine it from aluminium. So I'm sort of underway with that process at the moment. So yeah, lots to happen still, but I think I've got past the worst of it. So I'm going to say farewell for now. join me next time and I'll show you how I polished up those castings, and then we might be able to get a rough assembly done in the next video. Okay, it's Prezzo signing out for now. Thanks for watching today. I'll catch you next time. Cheers.